Welcome to Chapter 2 of Geometry. In Chapter 2, we start discussing the logic of geometry. We're going to work our way towards deductive reasoning and doing some proof by the end of this chapter. It's a different chapter. It's not very mathy. It tends to be much more logic-oriented, so you're not going to be doing quite as much of the algebra and stuff yet in this chapter. It's kind of a little break from that thing. It's definitely focused more on vocabulary and logic. So what we're going to start with the idea today is to start the idea of a conditional statement. A conditional statement, just reading, is a logical statement that has two parts. Hypothesis, we're going to abbreviate P, and a conclusion, we're going to abbreviate Q. When a conditional statement is written in if-then form, the if part contains the hypothesis, the then part contains the conclusion. So in words, if P then Q, or in symbols, and you'll see this symbolism a lot, P implies Q, or P arrow Q. So pretty common way of seeing that. We use conditional statements all the time. If it's raining, I'm going to take my umbrella. If it's Friday night, I'm going to the football game. Things like that. There are all sorts of conditional statements we do all the time. And writing things as conditional statements is something that's really more of an English thing than a math thing, but that's okay. So let's take a general statement and rewrite it as a conditional statement using if and then. All birds have feathers. Well, we can very simply write if it is a bird, or if an animal is a bird, then it has feathers. Okay, pretty simple conditional statement, not too tough, and something we can do without too much difficulty, writing it in if-then. If you had written, if it is a bird, then it has feathers, that would probably be okay. From an English standpoint, we want to have an actual subject in the sentence, not just two pronouns like it and it, but we're getting the idea of the logic here, which is the big idea in this case. If you are in Texas, if you are in Houston. Now this is a little tricky because we aren't going to stick with the same order because there's already an if here. If you are in Houston. So we already have the hypothesis part of this statement. So we have to keep that. If you are in Houston, now we got to just put the then you are in Texas. Now let's get back to the first statement for a second. Some of you are probably going, hey, wait a minute, you can't write that. If an animal is a bird, then it has feathers. Do all birds have feathers? Well, yeah, there are some. I guess if you plucked it, it doesn't have feathers anymore. If you pluck that chicken, it doesn't have feathers anymore. Does that mean it's not a bird? Of course, it's still a bird. I hope at least it was dead before you plucked it, but it's still a bird. So the question always comes up, hey, you can't write that because it's not true. I can write whatever I want as a conditional statement. Just writing it doesn't make it true. We can write conditional statements. They can be false. In fact, we're going to talk about truth value of a statement, whether a statement is true or false in the future. And so don't let the fact that the statement isn't true stop you from actually writing the statement. You can still write it. All 30-degree angles are acute angles. So if an angle is 30 degrees, then it is acute. X plus 7 equals 1 because x equals -3. The because, again, the because is a little bit shaky. So we could almost write this one either way. But generally I take the because is a then, so I'm going to say if 2x plus 7 equals 1, then x equals -3. I usually do it like that. The big thing is we're getting the if there and the then. The negation of a statement. To negate a statement is to say the opposite of the original statement. Now we have to be very, very careful with that because we have a little different definition of opposite that we normally use. For example, if I ask you what the opposite of hot is, you're probably going to say cold. If I would ask you the opposite of left, you'd probably say right. But in this case, the opposite is the negation, and it uses the word not. So the negation of hot, so if P is hot, the not P, the opposite, is not cold, it's not hot. If the statement P is left, the negation of that is not left. If the statement is red, the negation is not red. Okay, get the idea? So it's not opposites in the traditional sense that you would think of. In fact, I kind of don't like the fact that they use the word opposite here because I think that's confusing. I usually try to make a distinction between the negation and the opposite. So let's kind of ignore that opposite for now and say when we're talking about negation, we're talking about the negation of the statement, not what we traditionally consider the opposite. So the negation of the ball is red would be the ball is not red. The cat is not black. The negation would be the cat. Since you already had the not there, we're going to eliminate it. The cat is black. Good for the kids. Related conditionals. Now we're going to kind of cut this short a little bit. We are going to not really discuss these two so much. We're going to be mainly concerned with a statement and its converse. So if we have a statement, if P then Q, the converse switches the hypothesis and the conclusion. So the P, which was the hypothesis, becomes the conclusion, and the Q, which is a conclusion, becomes a hypothesis. In symbols, it's pretty clear, P arrow Q, Q arrow P. That's something we're going to be concerned about. So if P is you're a guitar player and Q is you're a musician, write the statement in words and decide whether or not it's true or false. So now we're not only going to write it, we're going to determine whether it's true or false. So P arrow Q, P is you're a guitar player, so it'd be if you are a guitar player, then you are a musician. That would be the statement. And would that be true or false? Well, I would consider that to be a true statement because if you're playing guitar, you're playing a musical instrument, and by definition, a musician is one who plays a musical instrument. So I would say that's true. The converse would switch the hypothesis and conclusion. So we'd still start with if, but we'd switch. If you are a musician, then you are a guitar player. Sorry, I ran out of space. All right, there's the converse. Now, is the converse true or false? Well, wait a minute. The statement was true. Shouldn't the converse also be true? Maybe, or maybe not. They're independent of one another. They could both be true, they could both be false, or one could be true and one could be false. It depends on what is being said. In this case, I'm going to go ahead and say that the statement is false. Now, if I'm going to say it's false, I have to give an example how it's false. And that example how it's false is called a counterexample. Now, the counterexample must still satisfy the hypothesis. So it's still, the person would still have to be a musician, but contradict the conclusion that the person is a guitar player. And so I could say Fred is a musician who plays trumpet. Okay? So there we are. A counter example. It's false, and we have a reason why it's false. I couldn't just say, John is not a musician. I don't want to contradict the hypothesis. I have to contradict the conclusion and agree with the hypothesis. All right. Now, logical statements and diagrams. Let's take a look at a diagram. What can I conclude based on a diagram? I kind of talked about this at the end of last chapter. Can I make a conclusion? AC is perpendicular to BD. AC is perpendicular to BD. Well, the definition of perpendicular, as you probably have learned well in the past, is lines are perpendicular if they intersect to form a right angle. We may not have seen this symbol before. So that symbol may be new to you. So let's kind of highlight that for us. This little upside down T symbol, that means perpendicular to. So, can I conclude that AC and BD are perpendicular lines? And the answer would be yes, I can make that conclusion based on that little red box. If this little red box here wasn't there, I would be out of luck. I could not make that conclusion. But in this case, I have to say, based on that, what I see, that is true. Angle AEB and CEB are a linear pair. Let's find it. AEB and CEB. Are those forming a linear pair? Yes, by definition of the linear pair, that is a true statement. They are adjacent. They do add up to 180. That's a linear pair. EA and EB are opposite rays. Well, let's check and see. EA and EB. Are those opposite rays? Nope, that's false. Explain the answer. That might be something like they do not lie on the same line. Opposite rays have to lie on the same line. Or opposite rays have to form a straight angle. They do not form a straight angle, they're forming a right angle. And that's the kind of thing we're going to be doing today. We're going to be working with the ideas of conditional statements, converses, and logic. And we're going to do this over a couple days, so don't panic. We're going to look at this again some more tomorrow. We're going to spend 2 days on this section because this is some pretty heady stuff. This is not your run-of-the-mill just solve for X situation. This is very different. So we're going to look at this in class tomorrow. We're going to look at this in class again the day after. We're going to have another podcast. So let's see what we can do with it. Hope you took some good notes, and I will see you in class.